Okay, so today we're going to be taking a look at parallelograms. So this would be the warm-up we would have done in class. So maybe take a look at that, think about what you know and how you might solve for x, y, and z based on what we know here. And it looks like I am missing one little piece of information. This is a trapezoid, so we should have some parallel lines there, shouldn't we? So you can pause the video, try that out if you want. And then come on back and we'll talk about it. Okay, so a couple of things we should be able to do here. First one, this is an isosceles trapezoid. So this angle here and this angle here are a base angle pair. They are equal to each other. So we've got 35 for y. Then, because it is a trapezoid, these two angles here are supplementary to each other. They do add up to 180. So 180 minus 35 gives me 145. That would be z. There. And then the last thing, since these are equal, it is an isosceles trapezoid, we can write an equation 2x plus 5 equals 3x minus 7. Typically speaking, the first thing we'll do is get the x's all on one side, so I'd subtract 2x. That'll give me 5 equals x minus 7. And then I'd want to add 7 to both sides, so 12 equals x. There you go. So next thing here, I know I posted these answers up on the Canvas page already. If you haven't taken a look at them, there are the answers. You can kind of pause the video wherever you feel like. Make sure if you missed any of those, you are contacting me if you're at home and asking questions on these. I'm not checking in on your individual homework assignments anymore if you're at home, so make sure that you are asking if you missed those, because that is how you're going to learn from this homework. So today we are talking about properties of parallelograms, and these are going to be things that are true for all parallelograms. And then later on, tomorrow and Wednesday, we will be talking about properties for specific kinds of parallelograms. Before we get too far into this, then let's kind of talk about those different kinds of parallelograms. So the first question I have always is, what makes a parallelogram a parallelogram? In other words, what is the definition of a parallelogram? And so the definition of a parallelogram is going to be two pairs of parallel sides. A trapezoid only had one pair of parallel sides. A parallelogram has two pairs of parallel sides. And so according to this book, a parallelogram is not a type of trapezoid, although it will have pretty much all of the same properties as a trapezoid. You can kind of think of it as a special kind of trapezoid. But anyway, two pairs of parallel sides. Now, there are special types of parallelograms that we've talked about before and we'll talk about starting tomorrow, and those are the rhombus and the rectangle. Both of these are parallelograms. So there's this like hierarchy of things. It's kind of like saying that you are a mammal, right? You are a human, but you are, of course, also a mammal. A rhombus is definitely a rhombus, but it is also a parallelogram because it is a special type of parallelogram, just like you are a special type of mammal. So a rhombus, actually, I'm going to put these back. I should have put the marks on the picture while I was up here. Parallel signs, parallel, parallel, and parallel. So a rhombus has those same things. It definitely has parallel sides, two separate pairs of parallel sides. What a rhombus adds on top of that is equal sides. All four are equal. And what a rectangle adds on top of that, besides the parallel things, sorry, I'm doing a terrible job of writing these on here. Besides the parallel sides, rectangles also have 90-degree angles. So those are the two different special types of parallelograms that we have, the parallelograms with equal sides and the parallelograms with equal angles. Then, of course, we know squares exist. Squares are just special types of each of these, kind of what they would have if they were both of them together. So a square is a parallelogram. It is a rhombus. It is a rectangle. It is all of them, but it also has kind of its own little category there. So it is a special type of rhombus in that it also has right angles. It is a special type of rectangle, and then it also has equal sides. It's a special type of parallelogram, just it has equal sides and angles, in addition to all of those things. So the big thing today is everything that we're going to talk about with parallelograms is also true of rectangles, rhombuses, and squares. Just that those other things are going to have additional new things about them. So here's what we would do in class, or what we are going to do in class. I've got a little handout that I give out, and we make a parallelogram on the actual grid paper here by creating some parallel lines using the grids, and then creating another set of parallel lines using the rise and run. So if I go, for example, over 2 and up, this one's 5. I can just pick any other point here, go over 2 and up 5, and I guarantee myself a parallelogram. So there's my parallelogram. And then what we do is we go through and we measure certain things, because we're looking for things that might be true about this parallelogram. And there's probably some you already know. The first thing I have students do is to take a look at the sides. And you will look here, and you could actually just use the grid paper here. If I were to go and count these, I'd have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Sorry, that's 7. I can count. So these opposite sides are not only parallel, which we already knew, but they are also congruent. And if you use a ruler or something like that, you can also measure these sides and see, okay, well, that one's almost exactly at 9, and that one also at 9. So these sides are congruent as well. Other things you might want to measure here or take a look at would be the angles. So if I were to get out a protractor and measure the angles, I'm going to find a few different things. So first thing I'm going to find here, this one looks like it's about 68. Just going to measure them all here. This one looks like it's about 112. And go up here and measure these other two. That one is also 68. And that one is also 112. So what you kind of see here is we've got a couple of things going on. The opposite angles, I'm going to do this one in blue, the angles across from each other are equal. You'll see that there, and that there, 68 and 68, and 112 and 112. So opposite angles are equal. And what you'll also notice here, if you add these up, 68 plus 112 equals 180. So opposite angles are equal, but angles that are next to each other, or adjacent or consecutive with the other fancy words you'll see, are supplementary, meaning they add up to 180 degrees. We've got one more to talk about here, and that's what happens when we draw in our diagonals. So I know I've got a lot going on in here. I'm going to go ahead and clear my ink off, and I'm going to draw in my diagonals. This would be something that I always have students do in class, and they'll be doing that in class this week. And I'll draw in my diagonals, and I'll draw in my other diagonal. And you'll notice, first of all, they're not perpendicular to each other. That's definitely not a 90-degree angle. But if you were to measure the different pieces that they make here, so if I were to measure that one, whoops. So that one looks like it's about 8.5. If I slide it up to here and measure the rest of the way, also 8.5. If I measure this one, from here to the middle is about 5.5. From here to the other end, also about 5.5. So what happens here is when you draw on the diagonals, they cut each other in half. They bisect each other. So this piece here is equal to this piece, and this piece is equal to that piece. So I can go in and just add in, like that piece and that piece are the same, and then that piece and that piece are the same. So all of the conjectures that we have are up here on the screen now. There's one down below. Make sure that you are adding these to your conjecture list. You're either keeping that blue packet or you are keeping your own list somewhere. This is very, very important. Is a lot of information. You need to be writing these down, and you need to be reviewing these. So in a parallelogram, The opposite angles are congruent. The consecutive angles are supplementary. Consecutive means next to. The ones that are next to each other are supplementary. They add up to 180. Add that in as well. Supplementary means 180. The opposite sides are congruent, and the diagonals bisect each other. They cut each other in half. Those are the 4 things that are true of every parallelogram, including all rectangles and rhombuses and squares. There are other things that are true about rectangles and rhombuses and squares, but these are true too. So we'll have just a quick couple examples here. Those ideas are going to get used, but the main thing is, can you figure out some other information? Can you use that in some way? So if you take a look here, we've got a quadrilateral, 4 sides, and we know the perimeter. Okay. But we only know 2 of the sides. We only have expressions for 2 of the sides. So how can I use that? Well, this one uses that, ended up being like the third one. But the conjecture that we talked about where the opposite sides are equal. If this is a parallelogram, then this side has to be the same as this side. And this side has to be the same as this side. So now we do have an expression for all 4 sides. And I can just add them up. So I add up my 2x minus 3 plus 2x minus 3, my x plus 2 and my x plus 2, and all told, added up together, we said the perimeter was 52 centimeters. So that's our equation we've got to solve. Now we're just back to some algebra here. We add up all our x's, 2x, 2x, x and x, should make 6x. Then we've got minus 3, plus 2, plus 2. Well, minus 3 is minus 6, plus 2 is minus 4, plus 2 is minus 2. So 6x minus 2 equals 52. And now we're back to something a little bit more like what you saw last year. So 6x, we're going to add 2 to both sides, equals 54. And divide by 6, x equals, is that 9? 54. That is, right? 54 divided by 9, yeah, it's 9. So x equals 9. Other things you're going to see, of course, are just questions where they're going to give you some of the angles. Now, in a parallelogram, they only actually need to give you one angle, and you can find all of the other ones. So if I have this and I tell you that's a parallelogram, and I put 110 degrees right here. Well, right away, I know this one's also 110, because those are opposite angles and they're equal. And then these two add up to 180. So if this is 110, 180 minus 110 is 70. And that one would also have to be 70. You'll also see questions with the diagonals, but just remember, the diagonals get cut in half. So your practice for today is going to be on page 284. I want you to do the first 6 questions for sure. Those are the kind of basic ones, not basic, but the ones that if you can do those first 6 questions, you are in a really good place. That is showing me that you've got a good understanding of what we've done. And you're in a good place to move on. If you're having questions on these first 6, those are ones you definitely need to be asking about because they are ones where those are things that we're going to have to build on. The rest of these, 9 and 14 and 15, these are questions that are a little bit more challenging for sure. They're asking you to make connections to things you might already know or might have learned in other classes. This one's a little bit more algebra related with the vertices. This one asks you to go back and think about things we did earlier in the chapter. Same thing here. But if you can do these first 6, what that's showing is you have a good understanding of this particular idea and you're ready to move on to the other one. If that's not the case, then you definitely need to be reaching out and asking for some help.